This is chapter 23, problem number 9. The problem reads, an 8.2 millihertz inductor is connected to an AC generator, 10 volts RMS, and 620 hertz. Determine the peak value of the current supplied by the generator. Alright. So, first things first, we have to understand what they're actually giving us, and they give us what will be our L value, which is our inductance. They give us our RMS V value, which they set as 10 volts, and they give us the frequency. So from that, and initially, we also know that we're solving for the peak value of the current. So from these variables, we can pretty much figure that we need to solve what we need to solve for the inductive reactance, and then plug our inductive reactance into this equation here, which we can ultimately solve for our average current value, and then from there we can manipulate that to solve for our peak current. But first we should solve for our inductive reactance. So for that, the equation is as indicated here. XL, which is inductive reactance, equals 2 pi times the frequency times the inductance in henries. So first, after applying that equation, we get our inductance to be, our inductive reactance to be 31.9. From there, we move on to this step of the problem, in which we actually solve for our average current. In this case, which we can do by taking the voltage over our inductive reactance, in which we attain a value. We can attain a value, current RMS value of 0.31 amps. But once we get to that point, we're not done. We actually have to go back into chapter 20 and find this equation here that actually allows us to solve for peak value. Peak value being symbolized by I naught. So to solve for I naught, we typically take our RMS value and multiply it by root 2, and then we would get our peak value of the current, which I found to be 0.44 amps in this case.